Alright, this is the homework sheet on the piecewise defined functions that I handed out. Evaluate f at -3. Well, -3 is smaller than -2, so I use this first rule. So that's going to be 3 times -3, the pen's not very good, plus 2, that's -7. F at -2, this means x equals -2. If x equals -2, I use this rule. So that's going to be 2 times -2 plus 1, that's -3. And f at 0, 0 is bigger than -2, so again I use this rule. 2 times 0 plus 1, that's 1. Now it asks me to graph. Well, what I know so far is I have the point -3, -7. That's right here. -3, -7. I know I have the point -2, -3. And I know I have the point 0, 1. Now, the other thing I know is that this 2x plus 1 graph starts right at x equals -2, and it has a dot right there, and it goes to the right. So I want a line that looks like that. Now, unfortunately, when x is less than -2, I'm going to have a different line. What I always like to do is I always like to plug in the split point, even though it's not part of this graph. I'm going to plug it in anyway. When I plug in -2 here, I get -6 plus 2, that's -4. So at -2, -4, right here, I'm going to have a circle. I'm going to have a circle because x cannot equal -2, but that does give me a second point that I can use that to connect my dots and draw the line. So there's what that first graph should look like. Okay, this second one. This first part confused people a lot. This says if x is less than -3, y is just the number -2. A lot of people wanted to take, when they plugged in -4, they wanted to take -2 and multiply it by -4. If I wanted you to plug in the -4 and do a multiply, I would have had an x right there. But all this means, if x is less than -3, for example, if x is less than -4, your answer is simply -2. When x is the number -3, you just get -2. Works right out. Okay? Now, when I plug -2 in, I've got to do a little work. When I plug -2 in, 2 times -2 is -4. -4 plus 1 is -3. Plug in -1. Still plugging into here. -2 plus 1 is -1. Plug in 0. Still plugging into this rule. That gives me 1. And then same deal here. When I plug in 1, I get just the number 3. There's no x there, so I'm not taking 3 times 1. It's just the number 3. When I plug in 2, that's bigger than 1. I get the number 3. The number 3. Okay, so what this graph is going to look like is this piece and this piece are just horizontal lines. Y equals a number is just a horizontal line. So I'm going to start by graphing those two. Let's see, I have x, when x is less than -3, y is -2. So I'll go to -3, -2. 1, 2, 3, 1, 2. So -3, -2, and I have a horizontal line to the left of that. And then similarly on the other end, I have the point x is 1, y is 3. X is 1, y is 3. I have a dot there because there was an equal to. And I draw that line. Now I have some points. I have -2, -3, -1, -1, and 0, 1. But I also want to consider what happens at the split points. So again, I think I want to plug 1 into here. When I plug 1 into here, I get 2 plus 1, which is 3. What that tells me is at 1, 3, I should have a circle. Now, notice at 1, 3, I already had the dot, so that's kind of interesting. That can happen. Sometimes the circle and the dot can match right up, and you just end up with what looks like a dot. On the other end of it, when I plug in -3, I get negative 6 plus 1, that's negative 5. So I should have negative 3, negative 5, which is down here, and a circle there. And then I could just connect. That graph should look like so. Now, once again, I do want to remind you that you can use your calculator for these. If you're doing a quiz or a test, that would be fine. I'm going to do the first one here. You go to y equals. You got to put it in parentheses, 3x plus 2. And then it's divide by another parenthesis, x. And to get the less than symbol, we go into this test menu. Second test, less than negative 2. And then you go down to y2 and you type in the other part. Oops, I need parenthesis. 2x plus 1 divided by x, again into the test to get the greater than symbol, greater than negative 2. Zoom 6. Now, again, the deal is, if you're drawing this on your quiz or on your test, you need to recognize the calculator makes a small mistake. The calculator does not clearly indicate which one should get the dot and which one should get the circle. So you need to look at your graph and recognize that this one has x less than negative 2. So that's this one because it's to the left. So you would need to recognize that you've got to put a circle there when you draw it on your piece of paper. Similarly, this one has the equal to, so you would recognize that you put a dot right there. So you have to draw that dot in that circle. That calculator does not do it for you. Okay, this is an interesting one, I think. I'm just going to make a little table here. And it's split at 0, so I'm going to put in a couple of my favorite positive numbers and a couple of my favorite negative numbers. When I plug 0 in, I plug 0 in there, I just get 0. When I plug in 1, I get 1. When I plug in 2, I get 2. However, when I plug in some negative values, something new happens. When I plug in negative 1, I've got to plug it into here, so I've got a minus, but then I've got another minus. A minus and a minus makes a plus, so that one turns out to be 1. When I plug negative 2 in here, negative and negative, again, is a positive. That one's 2, and that one's 3. So I have 0, 0, 1, 1, 2, 2, and then it would just keep going. On the other hand, I also have negative 1, 1, negative 2, 2, negative 3, 3. I'm not going to draw that one. Oh boy, that one I missed my dot, didn't I? I'm not going to draw that one. I'll just draw it like so. Looks like that. Now notice that this comes all the way down to here, and technically there's a circle right there at 0 for this left-hand part, because I can't plug 0 into there. But again, that circle and that dot happen to match up perfectly. Now, I didn't really expect you to know what this function was, that graph, but think about it for a second. That's the function y equals absolute value of x. What does absolute value do? It takes positive numbers and it leaves them alone. It takes negative numbers and it makes them positive. So, this is an alternative way, using piecewise defined functions, to write absolute value of x. Alright, the last thing we have here, finding these equations. What I like to do is I like to start by recognizing where is the function split. This function splits right here, and that's at x equals 0. So I have two pieces. I have one piece where x is bigger than 0, and I have one piece where x is less than 0. So I'm going to start with that part, if x is less than 0, and if x is greater than or equal to 0. I like to start with that part of my answer, start with the domain. And then I go ahead and I find the equation of each line. And the way I would do that is to just pick a couple points on the line. For example, there's this circle right here at 0, 1. So I'm going to use 0, 1. And then it looks like another point is maybe negative 3, 3. And you're approximating a little bit here. So some people gave me slightly different answers, but I'm going to use negative 3, 3. I would go ahead and I would find the slope. M equals 1 minus 3 over 0 minus negative 3. That's negative 2/3. So my equation for this part of this line would be negative 2/3 x plus 1. And it's plus 1 because that's clearly the y-intercept. Now, some people approximated using slightly different points, and you might have given me a slightly different slope number. That's okay. I didn't give you a nice grid here, so it's not exactly easy to tell where the points are. But I think I went with negative 2/3 for my slope. Now, for the second line, I do the exact same thing. I notice I have the point 0, 3. And it looks like I have maybe 1, 4. So my slope would be 4 minus 3 over 1 minus 0, which is 1. My y-intercept is clearly 3. So that one would just be x plus 1. Okay? This one we have 3 pieces. So when I go to write my function, I'm going to have 3 parts. If. It looks like there's one split right here at x equals negative 2, and another split right here at x equals positive 2. So I have one piece where x is less than negative 2. I have a piece in the middle where x is between negative 2 and positive 2. And I got the equal to there because there's the dots. And finally, a piece where x is bigger than 2. Now, the one in the middle is real easy. The one in the middle is just a horizontal line. Y is always the number 2 right there. I've got negative 2, 2, negative 1, 2, 0, 2, so on and so forth. So I can just write down 2 for that one. Okay, now for these other 2 lines, I would do the same sort of trick. I would pick 2 points. It looks like I have negative 2, 3, and maybe, let's see, negative 3, 4 maybe, in which case m is 3 minus 4 over negative 2 minus negative 3. That's negative 1 over 1. That's negative 1. Now, unfortunately, this time I don't see the y-intercept like I did up on this graph. Up on this graph, it came down, and I could see clearly the y-intercepts on both sides. I'm going to have to figure it out. So I'm going to use y equals mx plus b. I'm going to plug in my slope to be negative 1, and I'm going to pick one of these 2 points. I guess I'm going to pick this first one. I'm going to use 3 equals negative 1 times negative 2 plus b. Well, negative 1 times negative 2 is 2. When I subtract 2 on both sides, I get b equals 1. So this line looks like negative x plus 1. I'm going to be a little bit lazy here, and I'm going to skip showing all the work, but pick the point 2, 3, and it looks like 3, 4 is also on there. And you can check it out. Your slope for that one turns out to be 1 also. Do the same trick, plug in the slope, plug in a point, and you'll find that your b is also 1 there, which looks about right. I mean, if you just kind of extend this line down, it looks like it's going to hit right at 1, and that one also looks like it's going to hit right at 1. Okay, so you can take the time to work that out if you don't believe me, but I think it's right. Okay, this one. I'm not going to sketch the graph part on this one. I just want to talk about getting the functions. So, reading through this one, the amount of Social Security tax you pay, part of your Federal Insurance Contribution Act deductions depends on your annual income. You pay 6.2% of your income if it is less than $72,600. If your income is at least $72,600, you pay a fixed amount. Okay, so if you earn $40,000, then you're going to pay 6.2% of that. So you're going to pay 40,000 times .062. We take that percent, we convert it to a decimal. That's 40,000 times 0.062, 2480. Similarly, if your income is 65,000, they're still less than the 72,600, so you're going to pay 65,000 times 0.062. 65,000 times 0.062. I got 4030. Now, conversely, if your income is at least 72,600, then you pay a fixed amount. So if your income is 75,000, you pay a flat rate. You just pay 4501.20. And the same if your income is 100,000. You simply pay a flat amount, 4501.20. Okay, so here's our function. Tax, Social Security tax, in terms of income is, well, this function is split right at the 72,600. If my income is less than 72,600, I figure my tax out one way. On the other hand, if my income is greater than 72,600, I figure out my tax a different way. And we need to be careful, where does the equal to go? Let's see, it says if your income is at least 72,600. So that would mean equal to 72,600 or greater than. So it looks like the greater than or equal to should be there. And of course, there really should be that, because you can't earn negative income. If you left that off, I wasn't too worried about it though. Alright, so if you earn less than 72,600, you take your income and you multiply it by 0.62. So I'm going to write that as 0.062i. There's my equation for that one. Conversely, if you earn greater than or equal to 72,600, it's just a flat rate. A lot of people put an I right there. There shouldn't be an I right there because it's just a flat rate. I'm not multiplying that by my income. Simply flat. Okay, and then you can go ahead and graph that one later. Use your calculator if you want. Alright, now this one was challenging. Some people got it right, which was very impressive. Most people made a simple mistake. So it says, you plan to sell I Love Math t-shirts as a fundraiser. The wholesale t-shirt company charges you $10 a shirt for the first 75 shirts. After the first 75 shirts, you purchase up to 150 shirts. The company will lower its price to $7.50 per shirt. And finally, after you purchase 150 shirts, the price will decrease to $5 per shirt. Okay, so how much does it cost to buy 50 shirts? Well, to buy 50 shirts, you pay 50 shirts times $10 a shirt. That's $500. How much does it cost to buy 75 shirts? Well, for 75 shirts, they still charge you $10. So 75 times 10, which is $750. Here's where it gets complicated. What if you sell 90 shirts? If you want to buy 90 shirts, you pay $10 a shirt for the first 75. So for 90 shirts, you pay the $750. You got to buy the first 75 shirts at $10, and then what's left over, they only charge you $750. Okay, so you got to pay the $750 to buy the first 10 shirts. Then we're buying, or the first 75 shirts. Then we want 15 more shirts. So then they're going to charge us 15 times the 750. So that's 750 plus 15 times 750, which is $862.50. What a lot of people did is they just took $7.50 and multiplied it by 90 shirts. But that's not how it works. You pay the $10 for the first batch of shirts. Once you buy more than 75 shirts, the next batch is cheaper. Alright, so let's try that for 125 shirts. For 125 shirts, You buy the first 75 shirts. The first 75 shirts are going to cost you $750. Plus, now we're buying 125 shirts, so that's 50 more than 75, so I'm going to buy 50 more shirts at the $7.50 rate. So that's $750 plus 50 times 7.5, that's $11.25. Okay, now let's jump to 150 shirts. For 150 shirts, you got to buy the first 75. That costs you $750. Then you have to buy the next batch at $750. So that's an additional 75 shirts at $750. So that's $750 plus 75 times $7.50, $13.12.50. All right, getting close. Now 175 shirts. Well, to buy 175 shirts, I spelled shirts wrong. First, you have to buy 150. So you buy the 75, and then you buy 75 more to get up to 150. We know that's going to cost us $13.12.50. Plus, then we get 25 shirts cheap. We get 25 shirts at $5 a piece. So that's going to cost us a total of $14.37.50. And I think you get the idea now. To buy 200 shirts, first we have to buy the 75 shirts. That costs us $13.12.50. And then we're buying 50 more shirts at the $5. So $13.12.50 plus 5 times 50. Hit the wrong button. Try it again. I got $15.62.50. Okay, so what is this function going to look like? Oh, you couldn't see what I was writing there, could you? Sorry. There's all the things I wrote. Okay, so what is this function going to look like? We're going to have cost in terms of the number of shirts is, we have three different possibilities. The one possibility is if you buy between 0 and 75 shirts. The second possibility is if you buy between 0 and 150 shirts. And the third possibility is if you buy more than 150 shirts. Alright, so to buy 75 shirts costs you $10 times however many shirts you buy. That one's the easy one. To buy 75 or more, you first got to buy the first 75. That costs you $7.50. Or I'm sorry, $750 plus the remainder. So notice when I had 90 shirts here, I took 90 minus 75 to get 15. When I had 125 shirts, 125 minus 75 gave me the 50 extra. So this is going to be $7.50 times the extras. The extras is T minus 150. Oh, I'm sorry, T minus 75. The 150 is for the next one. Finally, to buy more than 150 shirts, first you have to buy the 150 shirts. That costs you $13.12.50, and then you pay $5 for all the extra shirts, and all the extra shirts are T minus 150. Again, if I wanted to buy 175 shirts, I would take 175 minus 150, which gave me the 25 shirts. And if I wanted 200 shirts, 200 minus 150 means I get 50 shirts at the $5. Okay, so this was a real tricky one. I would not expect to see something like this on a test, but I do think this is a pretty realistic situation. If you go out and look for buying large quantities of shirts, this really is the technique they use to sell them usually. Okay, I do think something like this problem would be a reasonable one to put on a test, and this is the sort of one you should prepare for. Okay, I hope that helps. If you have further questions involving piecewise functions, please don't hesitate to ask.